Alright, this is my third example of proving a Laplace transform without the table. And in this example, I have f of t is equal to t plus sine of 2t, also known as hyperbolic sine of 2t. It's interchangeable with me. And I have two formulas. The one that we always use in these examples, the Laplace transform of the first derivative, and the Laplace transform of the second derivative of a function. So where do we start? Well, my first step that I want to do is I want to prove the Laplace transform of t. And I know we did this in the last video, but I'm going to do it again. Just because I don't want to be that guy that says refer to this video. Because, well, what if you didn't see that video? What if this was the first video of mine that you ever clicked on? I know I shouldn't do that and repeat myself, but I guess it's good practice anyway. So let's just make the denotations, shall we? So the very first step that we had was h of t is equal to t, right? We realized that we had to take the derivative, and that's just 1. And now we take the Laplace transform of both sides, because I can make a relationship here. And also, we made the argument that I don't need to prove the Laplace transform of 1, because we're just going to make the argument that it's already given or known. And even if I didn't want to use the table, we made the argument in the video before this that I can easily, if I wanted to, find out the Laplace transform of this without the table, simply just using the definition. But that's going to take me like 3-4 minutes. Why would I do that? So we're just going to say we know this. So anyway, S, H, S, and H is 0 is 0, minus 0 is equal to 1 over S. That means that HS is equal to 1 over S squared. And that's obvious that we know that. So now what? So now we want to prove the second one, the Laplace transform of sine of 2t. And we're going to say that P of t is equal to sine of 2t. That means P dash of t is equal to 2 cosh of 2t. And P double dash of t is equal to 4 sine of 2t. I'm sure that's off the page by now, which it is, yes. Okay, so why did I take the derivative twice? Well, this is a concept I haven't explained in the videos before this. But basically, this idea of proving a Laplace transform without the table is only going to be able to work as far as I'm aware. I'm not sure, I haven't really explored it fully, but as far as I'm aware, the idea of proving a Laplace transform without a table is that you're able to make a relationship. And I'm able to make a relationship with the function here, the original function, because I saw shine again. Have you noticed that in every single the two examples preceding this, I was able to make a relationship with the derivative before this, or the function before this? Anyway, long story short, this works well with sine, it works well with polynomials, it works well with e, because all their derivatives, quote unquote, have families of derivatives. Anyway, so we're going to say, take the Laplace transform on both sides. So we're going to say s squared ps. Now, I know that P of 0 here is 0, so, by the way, I'm just applying the Laplace transform rule here, that's right here. So basically, s squared ps minus sp0, well, I know that this is going to go to 0. You can prove it yourself if you want to. And then minus p dash of 0, and that's just 2 times 1. Sorry, it's not 1. It's 2. I know this is 2. You can prove this yourself. If you plugged in p dash of 0 here, you'd get 2. And that's equal to, what's that equal to? Sorry, I'm just having a little brain fart. Oh yeah, 4 multiplied by the Laplace transform of sine of 2t, but sine of 2t is just ps. Alright, so s squared, alright, so we're going to do a bit of algebra, so we're going to take this 2 to this side, we're going to take this ps to this side, and we're going to say that ps s squared minus 4 is equal to 2, because this is minus 2, right? Therefore, ps, I'm sure you can see this shaping up exactly to what the Laplace transform of sine of 2t is. I know it's really bad handwriting, but basically the Laplace transform of sine of 2t is 2 over s squared minus 4, so we were able to prove that, which is fantastic. So therefore, the final answer is just sorry, not ft, fs is equal to hs plus ps. Therefore, I can just make the substitutions. The fs is equal to just 1 over s squared plus 2 over s squared minus 4. And that's the end of the video. Thanks for watching.